Okay, so I'm going to introduce you to C6 demo today. First of all, what is C6 about? What is the focus of C6? C6 is about enabling seamless data sharing between hosts and the accelerator. Essentially what we want to achieve is that as acceleration technologies start to get deployed for server acceleration, we want to make the data sharing between the host and the accelerator as seamless as it is between two processor cores. So what we are showing here is that in case of C6 now, the data can move implicitly because of a load operation and get cached locally, or the data movement becomes like a simple copy operation done at the application layer. There is no driver involvement and there is no OS support needed for that. What we are showing is applying C6 caching technology in the context of OVS offload. So essentially what happens is today when you do OVS offload, there is a caching layer that you have in the accelerator which is software managed. In case of a miss in this caching layer, the processing is slow and you have to now go to the host for processing the new coming packets for the new flows which are not in your cache, right? You can run into a situation here where a large number of packets come in for a given flow that has missed in the local cache and you cannot keep up with the rate of the incoming flows. What C6 allows you is to build a layer of caching in front of this software managed cache, and this is completely hardware managed cache, which then allows acceleration of the slow path that is serviced by the host.
Here we are showcasing a simple L2 level switching packet forwarding acceleration demo. What we have essentially here is our packet forwarding tables are stored in the host memory, and on the FPGA we have an Ethernet IP which is receiving the frames, and then we have a packet forwarding microkernel which is basically parsing the Ethernet frame, extracting the destination MAC address out of it, using the destination MAC address as a key and doing a key value lookup as an exact match unit. So in this case we have an Ixia traffic generator which is pumping the Ethernet frames into the FPGA, and then we have the logic in the FPGA which is extracting the destination MAC address, doing a hash on it and figuring out the pointer where the rules are located in the host memory. And then we are going over to the PCI Express link into the host memory to fetch the rules. Here we demonstrate two modes. One is the traditional PCIe mode, where for every packet we always go into the host memory to fetch the rule, and with C6 enabled link what happens is we go into the host memory for the first packet and then the rules get cached into the hardware cache which is implemented on the FPGA. Thereby for subsequent packets which hits the same flow, the latency is reduced. And in this demo, that is exactly what we are demonstrating. If you see, the red is the PCIe. With PCIe only link, we are able to service a lesser number of packets when compared to when we have a C6 enabled link, in which case because of the latency benefits we are able to service more number of packets. Now you may as well ask, we could even do a cache in a PCIe with a traditional PCIe scenario. The advantage with C6 here is in case you have an update to your packet forwarding rules, even though they are cached with C6, there is an invalidation which happens automatically because C6 is a coherent link. And to do the same over a PCI Express link, you need additional software and additional hardware to do that. So that's the ease of use with C6 here. Thank you.